2019 Exam 2 Data Analysis Question 5. Okay, we've got to interpret the slope of the least squares line. That's this, but we only want the slope. The slope is just this number. Just remember, they love in the exam, they always do this, y equals a plus bx, where a is the y-intercept and b is the gradient, also known as the slope, because that's what they're using in the exam. I don't know why we teach the word gradient when they'd say slope on the exam. And this is just one of those stock sentences. So there's slight variations on this, as long as all the words in there. You got to say on average. That's how you normally start it. On average, pressure at 3 p.m. and that's the Y one, increases. And we're saying increases because it's got a positive slope, and you can see the positive there. If it would be, you could say decreases if you need to, by 0.8894 hectopascals, the lovely unit of measurement that they love in meteorology, for every 1 unit increase in pressure. Ooh, got to squeeze this in, at 9 a.m. There you go. Little variations on these things. Roughly half the kids got this right. So, a bit like your SAC really. Should be able to do this by now. We're going to use the equation to make a prediction for the 3 p.m. when we know the 9 a.m. is 1025. That's the equation. All we've got to do is put 1025 into the right part of the equation. So we get 111.4 plus 0.8894 times 1025. You will get that equals 1023.035, but we want the nearest whole number. So that equals 1023. Make sure you pay attention to those roundings, whether it's whole numbers, decimal places, or significant figures. Don't want to lose the mark. Now, these are your poles. That's the ends of the data. And so inter means between the poles, the ends, and extra means beyond them. And if we look at this, we've got 1025. That's here. It's in here. So we're predicting between those two poles. So it is interpolation. So fairly straightforward so far. If you look at part B, lots of people got that one right. So that was good to know because it's just put it into your calculator. 84% and 87% managed to figure out it was interpolation. So people couldn't work out the number, but they could work out it was interpolation. All right, next part is determine the residual. Now it's on your formula sheet that they give you. So residual equals actual minus predicted. So we're going to get those two things. So we have got 9 a.m. is 1013 hectopascals. So if I look at my chart here and I read up, so if you look, that's 1013 there, and you go up, you get the actual values, the actual dot. So the actual dot there, and it's 1015. So we know this is going to be 1015. Predicted. Again, we've got to stick all those values into the calculator. So it's 111.4 plus 0.8894, but this time times 1013. And you're expecting a value about 112 when you do that, because you can read the graph. You go up and across, that sort of thing. And if you get that, you get 1012.3622. And so we're going to subtract 1012. And then what do you get? The answer of 3. And 40% of people got that right. So most people got that wrong. It says people who did it poorly, many found the predicted value correctly, but then subtracted from 1013. They didn't read the graph to get the 1015, because remember, this is pressure at 3 p.m. So you got to go off the graph for the pressure at 3 p.m. That was the thing. And yeah, that's where people went wrong. Oh dear. Okay, we're going to use the equation of the least squares line, this thing, and the information from the table above. We're going to need the standard deviations here to show, SAC-like kind of question again, that R equals this. Now you know that this is y equals a plus bx. Your formula sheet also has b equals r sy over sx. Remember, that's a multiply hidden in there. You're going to have to rearrange that equation. So you're dividing by sx, so you're going to multiply both sides by sx, so you end up with b sx, and then you're multiplying by sy, so you're going to divide both sides by sy, and that's what r equals. So that's when you rearrange the whole thing. Put a comma there just to separate that out. And so you know that equals 0.8894 times, and so the sx is this one, 4.5477 over the sy, which is 4.1884. Now, some of you might be bad at your algebra and rearranging equations, rearranging this to get this, but you should be able to check on your calculator that you did get 0.966. They already know the answer is 0.966. But if you're stuffed up and got your x and sy in the wrong way around, then you won't get 0.966. It's self-correcting. You can put in equals 0.966 in there. But yeah, don't forget that they've given you the answer. But only a third of people really got that right. Weird thing in the examiner's report says that some responses used a very messy, horrible, complicated formula. And it says, this is not part of the current study design. So there's probably some teachers out there who haven't read a study design for a while. That's a bit embarrassing, and they're teaching old things. Doesn't surprise me, unfortunately. All right, next one is what percentage of the variation in pressure at 3 p.m. is explained by the variation pressure at 9 a.m. You've heard that sentence before. That's your R squared. So you've got to take your 0.966 and square it. And so 0.966 squared equals 0.933156. But remember, R squared is a percentage. So we're going to multiply by 100. So you get 93.3156, but we only want one decimal place. So the 3 looks at the 1, says bye-bye the rest of you. It's 93.3%. A lot of people just gave R as 96.6%. Classic mistake. You've got to square it. Just remember that sentence, the percentage of the variation. That's the coefficient of determination sentence. All right. Obviously, I'm going to give you a big mark later on just for changing 90.966 to a percentage. Okay, this is the question that keeps on giving. We're up to part F now. The residual plot above, which looks like it's got a smiley face in there, so you'd have to do a transform to it. Hopefully they don't ask you to do that, because everyone hates transforms and does badly on it. It just says, what is the assumption about the association? So when you made that equation, remember you made that equation, y equals a plus bx. This is linear algebra, right? That makes a line. The residual plot is not showing that. So the assumption is that it's a line. So linearity, or it's a line. It's a line. The residual plot above does not support this. You can clearly see there's a pattern. There's a clear pattern in the residual. It's obviously going to need a transform. And that was 2 marks for that. Again, very badly done. 41% got part I right, 36% got I right. Many students had difficulty with the responses to these, often contradicting themselves or writing definitions directly from a bound reference without any link to the equation. Some confuse residuals and the correlation coefficient. Okay, when you're making the equation for the line, you're assuming it's a line. That's the thing.